Last unit, you guys found the areas of 2D figures, right? And I'm not concerned that you guys I don't want you writing it down or even to remember it, but I just want to make sure you're clear on how we're transitioning from the last unit. So last unit was two-dimensional objects. That was our circle, parallelogram, any of the polygons we found the area of, right? And I could probably add on some more here, triangle. All right, so now we're going to go and find some things for three-dimensional, which has length, width, and height. So have you guys heard of spheres before? Spheres, pyramids, I don't know why I always have trouble every year spelling that. Cones, prisms. This is what we're going to. These are all three-dimensional objects that now we're not going to find the area. Last unit we found the area of all these two-dimensional figures. We find what's called surface area. All right, that's surface area, and then the second half of the unit is how much inside volume. All right, so I just want to give you guys just a glimpse of the difference between last unit versus this unit. Let's just say the figures become more sophisticated. All right, they have length, width, and height now instead of just the 2D, which really don't have any depth to them. All right, ready to roll. Okay, before I even get into surface area, I want to make sure we are clear on some vocabulary. So this is called a polyhedron. All right, that's a cone, a sphere. All those are classified as like a quadrilateral. Any four-sided figure is a quadrilateral. Well, any of these are called polyhedrons. Every polyhedron has a face, edge, and vertices to it. All right, face, edge, and vertices. So let me go over what each means before we find out how many of them there are. Faces. Faces. Here's a face on this polyhedron. All right, there is a face on this polyhedron. Edge is what connects the faces. Here you go. I'm going to put it in red. CG would be one edge in that polyhedron up top. That's called an edge that connects the faces. And the endpoints of the edge, the endpoints are called vertices. So C, G, B, E, those are all vertices. Okay? So the edges connect the faces, and the endpoints of the edges are called vertices. So I want you guys to go to figure number 1 for me. We'll take our time here because we're brand new to this. Let's start with faces. How many faces are on this polyhedron, which I would call a prism? Some people maybe would call it a cube, which is fine. How many faces on that polyhedron right there? How many faces? Make sure you count the back, front, right, top, bottom. How many faces? Let's get this show going. 9? 6 faces. Good job. All right, now go. How many edges are there now? How many edges? Edges. The one big mistake kids always make here is counting an edge twice or a vertice twice. Make sure you count all of them once. How many edges are there? 13, Charlie? 12 edges. Good. There's 12 of them. And then go ahead and count how many vertices there are. How many vertices on this polyhedron? Vertices are the endpoints of the edges. Again, try not to count them twice. All right, how many vertices are there? 10? We're going to be here a while, aren't we? I might just stop this right now. 9? 8 vertices. Good work. Yep. All right, we'll do one more here together, and then I'll let you go on your own. All right, this pyramid. This is called a pyramid. We'll be working with that in a couple days. Pyramid. How many faces on the pyramid? How many faces on the pyramid? Counting them up. How many faces? 12? 3. This is fun. 12. 3. 12. 2?
Faces.
Faces.
5.
5. Edges. How many edges on this polyhedron? 9. I got 8. Sound confident. Yes, 8. And then how many vertices? On this pyramid? 3. 5.
Wait. Oh, 5.
5. I don't know if you were actually.
Wait. Are you talking about number 2? Oh, number. Okay. Vertices.
Just stop. We're good. We're on number 2.
Oh, we're on number 2.
I called your number 5, which happened to be the answer. So I know that definitely just blew a gasket in your mind.
Yeah.
So it's 5. We're all good? All right, go ahead, number 3. You guys go ahead and get them on your own, and I'm going to show you a little way that you can check yourself to see if you have the right amount. Ready to roll? Faces. I'm just going to do this one. 5, edges 9, vertices 6. And that's a triangular prism, if anybody's a triangular prism. Everyone's good. All right, if you ever want to check yourself, all right, because you could miss one, you could count one twice. Here's a way to check yourself. This one, and just some backstory, because I know you don't care one bit, but I'm going to tell you anyway. 1800s, a mathematician by the name of Leonard Euler. Yes, Euler. And it's actually spelled like this. All right, it's not Euler. Leonard Euler was doing, I don't know how he discovered it. He must have done a bunch of these and discovered a pattern. And here's the pattern to check if you have the right number of faces, edges, and vertices. Faces plus vertices, if you add the faces and vertices together, and then subtract out the number of edges, always, it doesn't matter what the figure is, always will equal 2. Try it out on one of them that we just did. Faces plus vertices minus edges always equals 2. Always. Amazing. So if you ever want to check, I'm never going to have you require it, but if you ever want to check you have the right amount of all of them, you can plug it into that formula, Euler's formula. Faces plus vertices minus edges equals 2. Amazing, huh? All good? Everyone good with faces, edges, and vertices? Okay, next up. Cross section.
Oh.
All right, cross section. Here is how a cross section is formed. You take any polyhedron, okay, and we're going to slice it up. Okay, we're going to slice it. So let's say I take my tissue box, I cut it right down the middle, if I could, all right, and then I hold up what I cut, and I want to know what shape is formed when I hold it up. Like for instance, if I took my tissue box right now, sliced it down the middle, took that slice and held it up, what figure would be in front of you right now? What would that figure be that I'm holding up? If I took this, sliced it right down the middle, held it up, what would it be? It would be a rectangle, depending on what it was originally. Yes. Okay. Let's take my cylinder, and I'm going to cut it this way. It all depends on how I cut it, right? If I cut it this way, hold it up to you guys, what would it be now? What shape? Circle, right. That would be a cross section of a circle. But say I told you I cut it down this way. Wouldn't be a circle anymore. Think about it. If I sliced it down this way vertically and held it up, wouldn't be a circle. Would be a rectangle. Right? Here you go. Right? It's all good. I'm glad you're having trouble with that. Here you go. And that's why I have this today. Take a look. Where's my cylinder? Right here. So everyone sees that's what we talked about. I slice it horizontally, right? Now let me slide it. Let me do vertical now. It's not going to let me. It's never usually. Oh. All right. Anybody? There we go. So if I slice it vertically, see it?
Oh, I thought you were talking about like the actual figure, like.
No, all it is cutting right down the middle with it.
Oh, okay.
Okay, and that would form a rectangle.
So you're saying like the top thing, like it's.
Like if I slice it,
Yeah.
right now I have two halves, right? If I take one half, take it out, and what figure am I showing you right now?
Okay.
Not a half cylinder, I'm showing you a rectangle right now. Okay? Everyone else good? How a cross section works? Now it all depends on how you slice it too. Okay, it all depends because you guys just saw here, if I do it horizontally, it's a circle versus vertically, it would be a rectangle. And it depends on the figure too. All right, so here are just some different cross sections right here. Any questions there? Because you guys are going to practice cross sections right now on the next page. All right, so which figure can have the same cross section as a sphere? Well, let's talk about a sphere right now. Let me go back to my figures here. Spheres. I don't care how you slice a sphere, what's going to be the cross section? Always a circle, right? Now, here's horizontal. Look, I don't care what direction, angle I slice this figure, it's always going to be a circle. So now I'm asking in this question, hey, what else would have a cross section of a circle? So look through those figures to, decide, all right, I'd slice it this way. Would I get a circle? What about this way, this way? Which one of these four figures here would I also get a circle back if I did a cross section? And it would be which figure up here? Where else would I get a cross section here? 2, the cone, yep. How would I slice it? Horizontally, right? I hold it up, I get that circle back. Good job, everyone. Good work. All right, a little bit tougher question now. I'm going to take my cone, do as many cross sections as I can. Which one of these would not be a cross section? All right, so think about a cone. I slice it horizontally. I slice it vertically, maybe diagonally. Which one would I never get up here? All right, which one would never be a cross section I could show you? All right, so here's my cone. I could slice it horizontally and get the circle, so that's not a choice. All right, let's keep rocking and rolling here. Still a circle. Oh, look at that bad boy. Diagonally, I get that little arch-looking figure. Let's keep going. It's down to the square and triangle. Which one will I never see? And then what if I do it vertically? What do I end up with? A triangle, right? So the one I would never see is the square. All right, everyone good? Cross sections, faces, edges, vertices, so we can start talking about our first 2 polyhedrons here. Let's do it. Told you, big day today, longer day. All right, here's a polyhedron, and here's how we're going to name it, because I just don't want to call it, we're going to call it a prism, but more importantly, I just don't want to say prism. I want to put more detail to it. As you guys can, I didn't put this on your notes, but I put up a bunch of prisms right here. Like this is a triangular prism. Why would I call it a triangular prism? This is a rectangular prism. Why would I call it rectangular? Pentagonal prism. Why would I call it pentagonal? Because it all depends on what shape their bases are. Okay? What shape the bases are. And the bases, all right, are always parallel and congruent to each other. That's how I know what the bases of a prism are. They're just the 2 that are always congruent and parallel. So everyone see this one I put up here? What shape are the bases in this one? What's the shape of the base? What is that shape on the top and bottom? Pentagon, right? So I'd call this a pentagonal prism. You name a prism by its base. All right? All right, 2 different areas we're going to find. Two different areas. First one's called the lateral area. Let me explain what lateral area means. That's the area of the faces. Remember what the faces were we talked at the beginning. The area of all the faces, ready? Excluding the bases. So I don't count the bases when I find the lateral area. So I take all the faces, pop off the bases. I know it's a little rhyme time here, right? I'm a poet, didn't even know it. Got that name? Pop off the bases, find the area of everything that's left, which we did last unit. All right, so if I say find the lateral area, you'll pop off the bases, find the area of everything's left. If I ask for surface area, that's the whole darn thing. Put those bases back on, we're finding the area of every single face. All right, so this is the area of all faces, surface area. And I know we changed the notes and you guys just have this prism right here, so we'll just do that one right here. All right, so everyone ready for number 2 here? Or my number 2, your number 1. Find the lateral area first. All right, before we even start, what's the name of that? What name would you give that prism? What name would you give it? You name it by its bases, Anna? Triangular prism, because the bases are triangles. So ready? If we're going to find the lateral area, everybody pop off the bases right now. Pretend they don't even exist. How many faces are left now? Pop off the bases. How many faces are left? 3, and they're all in what shape? Rectangles. So now to find the lateral area, we're going to find the area of all 3 rectangles that are left over. Does that make sense? Lateral area. Take off the bases and find the area of everything that's left, which in this case would be 3 rectangles, the bottom, the right, and the left one. All right, so lateral area, I'm just going to abbreviate LA if everyone's all right with that. Lateral area. Can you give me the dimensions of one of the rectangles that we're going to find the area of? Give me the dimensions of one of the rectangles we're going to find the area of. 11, Kelsey? That's the bottom one. Everyone agree? The one's on the floor. 12 times 16 plus, there's one more you'll be able to find real quick. How about the one to the left? What are the dimensions on the one to the left? 7 here?
No.
Kara?
9 times 16.
9 times 16. Good work. Everyone's all right? Now, the only one we need to still find is this one to the right. And I'll highlight that in orange. How do I find that one? Well, I know it's going to be 16 times something, right? How do I find the other side? What can we rely on here? Which we've relied on all year, it seems like. Pythagorean theorem. Yep. And I see a lot of you guys are already starting to do that. Good. Nine squared plus 12 squared equals c squared. Let me know when you have it. This is bad. 1, Anna? 9 squared plus 12 squared, take the square root of that. 15, good work. So 16 times 15. And there you go. There's the lateral area. So I add them all up. Multiply, add them all up. And I'm not even going to worry. 576. If you guys are units, we're still finding an area, lateral area. So you would still square the units if you put units on it. All right, we still square. All right, part B, let's find the surface area now. All right, it asks for lateral and surface, right? All right, you guys are almost there. Remember what surface area is? Everything, all faces. Hey, We already know 3 of them add up to 576. Now we just got to put the bases back on. And remind me one more time, what shape are the bases? Triangles. And we have formulas from last unit for that. And you have 2 of them which are congruent. So watch. 2 triangles that are congruent times 1/2 BH. Because that was the formula of a triangle. Everyone all right with that? And yeah, I know the 2 and the 1/2 cancel, but I'm showing everything. Everyone all right? Why I'm doing 3 faces we already found the area of, plus the 2 bases coming up. 576 plus 2 times 1/2. They're right triangles, and we talked last unit. The base and height of a right triangle are just another, what's another name for them? You got 2 of them, you walk with them? Legs, a good name. Good, you're good. You picked up on that. 9 times 12. Again, lateral area, take off the bases. What's up, Charlie? Sure, go right ahead. 684. And please, not a life lesson, but a common sense lesson here. I think your surface area should always be greater than your lateral area, right? Because you're adding on more faces. All right, how's everyone feel there? We're okay? The concept of lateral area and surface area now. All right. I still have to talk about another figure though, and that's the cylinder. Cylinder is just a prism with what type of bases? Circles, right? All right. So here's the problem we're going to run into though. Everyone think about a cylinder, or you can think about my spool of thread here. You take off the circles. I don't know what, I have no idea. You're still left with like a cylinder, aren't you? All right, so this right now is going to require a formula that we need to remember. All right, the lateral area of a cylinder. And that's going to be 3 simple letters. No, actually, no, two letters and a symbol. Pi D. Where have we seen that before? Dig deep. 2 units ago. Circumference formula, yep. Pi D times H. So real quick review, D is for the diameter of the circle, and H now? Height of it, height. That's the height, yes. Pi DH, that's something that's not on your formula sheet, that's on you. And then surface area. Okay, think about it. Give me the definition of surface area. I take the lateral area, what do I put back? I take the lateral area, pi DH, and what do I put back on now? Right? Dig deep here. What do I put back on? For the surface area, I take the lateral area and put on what? Well, okay, the bases. What shape are the bases in a cylinder? Circles. What's the area formula for a circle? Last unit. Pi r squared, and how many do I have?
2.
So what am I going to add on? Put it all together now.
Times 2.
Plus 2 times 2 circles. I'm putting back on pi r squared. There it is. Pi dh for the circumference times height, and then pi dh plus 2 pi r squared. All right, let's go through a couple of these. I'm going to go through these pretty quick because it's just plugging in numbers, really. I just want to make sure you guys know the formulas. Find the lateral area here. Right, that's what you guys do. Lateral area, yep. All right, so pi dh. Pi, diameter is already 10. Now take a look here. I know we're going to plug in 2 because that's the last number left. Height. Listen to my definition of height of a prism. It's the segment that connects the bases. Find the segment that can, or the edge that connects the bases. That's your height. Whatever edge connects the bases. You see how this 2 here is connecting the bases together? That's how I know it's the height. So if you have multiple numbers on a figure, the height is always the edge that connects the bases. And round to the nearest tenth. I'm going to get moving here. 62.8. And it's lateral area, so we can square the units. All right, next one. Pi dh. What am I plugging in for d real quick?
6.
Times 2, yep. 3 times 2, 6. Height is 6. Everyone see what I'm starting to talk about. Whatever edge connects the bases. That's your height. Plug it all into your calculator. (113.1 square meters). All right, ready to go surface area now. Okay, number 5, surface area. Pi dh plus 2 pi r squared, the two circles. What's everyone plugging in for diameter? Diameter of this cylinder? Diameter? Double it?
2.
2. All right, just making sure we're good. 2, height of 3, plus 2 pi 1 squared. Just make sure you're going. I always get nervous with that formula because diameter's on one half and r's on the other. What do we have to leave our answer in terms of pi? All right, let's talk how we do that here. Hey, I'll go slow now. Everyone agrees 6 pi? 6 pi. Over here, I get 2 pi. Do I have pi's on both? So you can combine them. As long as you have pi's on both, you can combine them. So my final answer in pi here would be 8 pi square meters. Whew. And then how about 6? Diameter, they tell me, is 7. Height, I can definitely tell the height. Connecting the bases is 10. Plus 2 pi. Make sure you don't plug in 7 again. That's my worry. It's the radius now. 2 pi r 3.5 squared. All right, 70 pi on the left. And then what are we getting over here? I have no idea. 24.5 pi. Because I got to leave my answer in terms of pi. So we end up with, you can combine those, 94.5 pi. What's it, centimeters squared? Anything you want to ask before I end it with some fireworks? We're always going to end class this way with this type of problem coming up. Where I take whatever 2 figures we just learned about, put them together, and I ask you for the surface area. Let me give you a more detailed definition of surface area. Surface area, everything on the outside of the figure that's not covered up. Okay, that's not covered up. So this when I do this problem with you guys, it's just not going to be cube plus cylinder and I'm done. Surface area, everything on the outside that is showing, aka that's not covered up. All right, everyone see what I'm talking about? So I'm going to do cylinder and cube, but I'm not going to do the full surface areas of both and just add them together because I got some stuff that's covered up. So let's do, you want to do cylinder first? Let's do the cylinder first. And then I'll do the cube. All right, so let's do cylinder. And I need you guys here to talk to me about this. Here's the surface area formula of a cylinder. Pi dh plus 2 pi r squared, right? but not the full cylinder is not showing. What's being covered up? Talk to me. What's being covered up in this cylinder? What's not on the outside, not showing on this cylinder? Kelsey? One of the bases, right? One of the circles. So I'm not going to do 2 pi r squared for this one. Make sense? Because this base right here is being covered up. So I can't count it. We're all good. All right, so let's find that area. Pi, diameter they tell me is 4. And hold on, can we just take a time out here because the textbook does this a lot? Take a look. Everyone see it. You would think that they're just pointing to the radius, but if they draw the full diameter in, that's what they're talking about. Okay? I know you might look at it and say, oh, they're just pointing to the radius. If they draw a radius in only, yeah, that's 4. But if they draw a full diameter, that's what they're talking about. What's the height of this cylinder? Also 4 plus pi. The radius would be 2 squared. If we want to go further, 16 pi plus 4 pi. So that looks like it's 20. I'll just leave it in terms of pi for right now. 20 pi for the cylinder. And you don't need to go that far because we're just going to add it to something else here in a second. Everyone's good so far? You ready to go for the cube? All right, let's go cube. Surface area. How many faces are on a cube? How many faces are on a cube? 6, right? And they're all the same. So 6 times, what's each face measure? They're all the same. 5 times 5, right? Everyone's with me so far, 6 of them. But I hate to break it to you, not all 6 are showing. Full faces are showing. 5 of them are, right? So what am I going to have to subtract out here that's being covered up? Everyone see the face that's part of it's being covered up right here? What's covering up? What is that figure? That's a circle, right? So I need to subtract out pi r squared, that circle that's covering up on one of those faces. All right, so 6 times 5 times 5 minus pi. We know the radius we already said was 2 squared. Everyone all right why I'm subtracting that out? Because it's covering up that 5th face or that 6th face. We okay? So go ahead, find that area, and then I add the 2 together to find the total surface area. Rounded to the nearest. Oh, I don't have any directions, do I? We'll go nearest 10th. Let's go nearest 10th here. Should have put those directions on. So you want to add those together now. Because I'm trying to find the total surface area. How we doing? 200.3 look good? Square inches. Surface area, everything showing. You can't count what's covered up. All right, lateral area, take off the bases. Okay, lateral area, take off the bases, find the area of all the faces that are left. Questions? Okay, again, as you guys are starting to see here, as we progress in the units, the assignments get shorter and shorter. So at least give it what you got here. We got 4 tonight. And packet page 6, which I would recommend starting right now, that's all cross-section questions. Okay, so at least get done the packet work. Also, I don't know how easy it is to access the online textbook, but I'm going to have to do this next year because we're getting rid of all the textbooks and the online textbooks. So I'm going to try to pilot it with you guys. Up on Classroom, I have all the Unit 12 textbook pages that you'll need this unit. All right, so you just have to open it up, textbook pages. Hopefully this works, huh? All right, here's day 1, all of the pages that you need for day 1. Find what you need. And find the problem. Okay, so if you want to access it through Classroom now, you can. All right, or if you want to keep using your online version, go right ahead. But they're all on Classroom now too.